Hello everyone. We are Unit 2, Lesson 1, hopefully 1 and 2. We'll see how far we get. So bear with me. I'm still learning this technology and the writing on the screen. So sometimes I have to pause it. Someone comes in or I'll put some stuff on the calculator. So that way you just don't have to watch me input the information in the calculator. It'll save some time on the video. So like I said, we're the introduction to functions. Here up at the top. Okay, let me get the pen going up here at the top. Most higher level mathematics is built upon the concept of a function. Like most of the important concepts in mathematics, the definition of a function is simple to the point of being overlooked. Make sure to know the following definition. The definition in the box. A function is any rule that assigns exactly one output value. So the y value is the output for each input value, which is an x value, input and output. These rules can be expressed in different ways, most common being equations, graphs, and table of values. We call these input value variables independent and output dependent. So I remember input with the I, independent, so the I's go together. So if we're looking at exercise 1, an internet music service offers a plan whereby users pay a flat monthly fee of $5 and can then download songs for 10 cents each. So the independent, your input values. So the input value is the number of songs. Okay, see how it's kind of weird, the writing? And then the dependent, okay, so it's your output value. So what do you do once you find, or what do you find out once you determine how many songs you have downloaded? You find the cost per month. Okay? So we are able to fill in the table for the variety of independent values. So this one's pretty basic. It's 10 cents each. So if I have 0 downloads, that's going to be $5. That's going to be my charge. If I have 5 downloads, 5 times 10 is 50 cents. That's going to be $5.50. 10 times 10 cents is $1. That's going to be an amount charge of $6. 20 times 10 is $2. Plus 5 gives you an amount charged of $7. So they want the number of downloads to be represented by the variable x, and the amount charged in dollars be represented by the variable y. Most in terms of x and y. Sometimes they're not. If they tell you specifically that you have to use a and b or anything else that they want you to use any variable, you have to, or you will lose points. So the equation is y equals $5, that's where you start with, plus 0.10x. So you would rewrite it as y equals 0.10x plus 5. Because I like it in this form, y equals mx plus b. Now once you do this, they want you to use that equation and then graph the function between 0 and 40. So I'm going to pause it and put it all in the calculator. You won't know I'm pausing though. See, you didn't even know I was gone. Okay? So I put it in the calculator. I put the formula 0.10x plus 5. This is a snapshot of the graph. So they want us to generate additional coordinate pairs to the ones you found. So if I want it between 0 and 40, technically what I'm going to do is I'm, of course, going to find what 0 is. I'm going to find what 40 is, and then a couple in between. You can, if you want, use the table. So I'm going to go Control T for the table. Okay? So 0 is 5, of course, because that's the y-intercept. 10 is 6. And then 20, see how we're just scrolling down, is 7. 30, I passed it. 30 is 8. And 40 is 9. So when you go here, 0 was 5. 10 was 6. And how do they go up? 1, 2, 3, 4, 5. So it's 250. So they're going up by 50 cents. So that's 6 and that's 7. So 5 and then 10 goes to 6. 20 goes to 7. And it's tough for me sometimes to line these up on this screen. 30 goes to 8. And then 40 goes to 9. It's a linear equation, meaning it's a line. Of course, we will use a ruler, but that's not a bad straight line right there. Okay? You keep practicing, maybe you'll be able to do it that well without a ruler. Okay? That's it for the first part. I got a fly buzzing around me too, so I'm waving at it. So now, of the following graphs, exercise 2, where y is a function of x. Okay, so 1 does not. So we have relationships where y is a function of x and 1 is not. Darn fly. Draw the vertical line whose equation is x equals 3 on both graphs. So we have this graph, it's an oval, and then we have a parabola. So x equals 3. Now you got to be very careful because sometimes you put it the wrong way. So if I want to draw x equals 3, I find where 3 is on the x-axis, which is right here. And then I draw a line right through it like that. Okay? Same thing in the next one. X is 3, 1, 2, 3 right here. And draw a line through it like that. Okay? Now, draw the vertical line. We did it. Give all the output values for each graph at the input of 3. There's 1, there's 2, 1, 2, 3, 4. So it's 4 and negative 4. Okay? I would accept that. That's fine. Some want it in numerical order, so from negative 4 to 4, that's okay. Use some sort of bracket. Okay? Do not use a parenthesis because then it looks like an ordered pair. So this represents the solution set. And that's relationship A. Relationship B is just this value right there. And they want the output values, they want the y values, so that's negative 2. All right, so explain which of these relationships is a function. So remember, a function has to pass the vertical line test. Should be review. The vertical line test. If it does not pass the vertical line test, it is not a function. So in exercise 3, the graph of the function y equals x squared minus 4x plus 1 is shown below. Okay, so this is it over here. State this function's y-intercept. Y-intercept right here. So the y-intercept. Now, I would accept 0, 1. Sometimes they will show 1, okay, which is also acceptable. Then it says between what two consecutive integers does the larger x-intercept lie? This is an x-intercept. I don't know if you can see it. And this is an x-intercept. So they want the larger one, which is right there. It falls between this number and this number. 1, 2, 3, 4. So it falls between 3 and 4. Draw the horizontal line y equals negative 2 on the graph. If you don't know, put it in your calculator. Y equals negative 2 right there. Okay? Y equals negative 2. So we drew it. Use these two graphs, find all values that solve the equation below. So what they are looking for is the points of intersection. Okay? So we want to find the values of x. All right, we already know the y value. We already know the output, so we're looking for the input. So the y is here, or x is here and here. So it's 1 and 3. Okay? Those are the values of x that solve for the equation below. All right, very well. If you need to rewind or pause it or whatever else, make sure you do that as I am going over the lesson so you don't miss anything. And if there's any questions, put a little note or an asterisk in your notes so that you can ask me when you come to class. We've got about 6 minutes left. I'm going to see how far I can get with lesson 2. Now, you might need to pause this to find where you are. So I am lesson 2 with exercise number 1. So it says function notation. And I did number them for some people who were asking me to number. So I didn't number mine, though. It might be page 5. Okay, page 5. So functions are fundamental tools that convert inputs, values of independent variables to outputs. values of the dependent variable. There's a special notation that's commonly used to show this conversion process. First exercise will illustrate this notation in the context of formulas. Okay? Evaluate the following. This is just your such that. X equals. So we have 3 and negative 2. This is 13. This is negative 12. We went over this. That's why I'm just kind of giving you the answer. What you should do is if you have your calculator, plug it in to make sure you can get this. This is 13. This is 4. Okay? The last one, hx equals 2 raised to the x power. H of 3 is 8. H of negative 2 is 1/4. And if you put that in your calculator using such that, it'll all give you these output values. And here's your function notation. Y equals f of x. X is the input. Y is the output. F of x is the function of x. So recall the function. That function rules commonly come in one of these 3 forms. Equations, like exercise 1, graphs, and tables. Now we're going to look at a table. So exercise 2, here's your boiling water. Fahrenheit left the room at 65 degrees Fahrenheit and begins to cool. The temperature reading are taken each hour and given in the table below. In this scenario, the temperature is a function of the number of hours. So evaluate T2. So T2. Okay, so 2 is H. So here it is right here. You're finding the output, which is 104. T6, 6 is H. The output is 68. Now we want to find the hours in letter B. For what value of H is T of H equals 76? There's your 76. They give you the output. So H is 4 for the input. Between what 2 consecutive hours will T of H equal 100? So T of H, so that's your output. It's right in here somewhere. Okay? So that between what 2 consecutive hours? Between 2 and 3. Okay, that's where it will be 100 degrees. Okay? Exercise 3. Again, if I go too fast, pause it, slow it down, rewind it, whatever you have to do. Okay? I'm thinking this is all review. So the function y equals f of x is defined by the graph below. Answer the following questions. Evaluate f of negative 1. X value, x value, x value. So we want the y. At negative 1, we're at that point right there. So that output is 0. At 1, here's x is 1. My output is up here, 1, 2, 3, 4. At f of 1, we're at 4. At f of 5, 1, 2, 3, 4, 5, right here. That's the input. This is the output. Come over here, 1, 2, 3, 4, negative 4. Okay? So input versus output. Evaluate f of 0. What special feature on the graph does f of 0 always correspond to? So f of 0. All right, so be very careful with this. X is 0, which is here. Okay, here is my output. So it's 3. Okay, now what special feature? This is the y-intercept. Okay, what values of x solve the equation f of x equals 0? So where those are is here, here, and here. Those are the zeros. So I have negative 1. I have 1, 2, 3. You're just counting. And I have 7. So 1, and 1, 2, 3, 4, 5, 6, 7. So negative 1, 3, and 7. And then it says, between what 2 consecutive integers does the largest solution to f of x equals 3 lie? Okay, so where is the largest solution? And I'm running out of time here. So it is between 7 and 8. Okay, because that's where the largest solution will lie. Okay, I will pick up with exercise 4 in class. If any questions on these lessons 1 and 2, ask me before we start going over the fluencies and starting to work independently. Okay, well, hope you had a good weekend. All right, see you in class.